During World War II, the Nazi regime embarked on a series of ambitious projects to develop secret weapons, hoping to turn the tide of the conflict in their favor. These so-called Wunderwaffe, or wonder weapons, range from advanced aircraft and rockets to experimental tanks, and even rumored superweapons. The motivation behind these efforts stemmed from Germany's increasingly desperate position as the war progressed. Leaders believed that technological breakthroughs could deliver a decisive advantage on the battlefield. The stakes were immense, as both sides raced to outpace each other in innovation and firepower. Ultimately, the pursuit of these secret weapons reflected both the ingenuity and the desperation of a regime fighting for survival. During World War II, both the Allied and Axis powers were locked in a relentless technological race. Each side invested heavily in research and development, seeking to create advanced weaponry that could tip the balance of the conflict in their favor. Innovations ranged from improved aircraft and tanks to more sophisticated naval vessels and radar systems. The pursuit of new technologies extended to rocketry, with Germany's V-2 missile marking a significant leap forward. Meanwhile, the Allies focused on code-breaking and the development of the atomic bomb. This intense competition not only shaped the outcome of the war, but also laid the groundwork for many technological advancements in the years that followed. The V-1 flying bomb, also known as the Buzz bomb, was developed by Nazi Germany as one of the earliest cruise missiles. Introduced in 1944, it was designed to target cities like London and Antwerp, delivering a payload of explosives over long distances without a pilot. The deployment of the V-1 marked a new era in warfare, as its distinctive sound and unpredictable trajectory instilled widespread fear among civilian populations. Despite efforts by Allied forces to intercept and destroy these weapons, thousands reached their targets, causing significant casualties and damage. Strategically, the V-1 forced the Allies to divert resources to air defense and countermeasures. Psychologically, it aimed to undermine morale and create a sense of vulnerability far from the front lines. The legacy of the V-1 highlights both the technological innovation and the human cost of total war. The V-2 rocket marked a pivotal moment in the history of technology as the world's first long-range guided ballistic missile. Developed during World War II, it was capable of delivering a warhead over hundreds of kilometers with unprecedented speed and accuracy for its time. The V-2's innovative use of liquid-fueled engines and gyroscopic guidance systems laid the groundwork for future advancements in rocket technology. Although originally designed as a weapon, its underlying engineering principles became the foundation for post-war space exploration efforts. The expertise gained from the V-2 program directly influenced the development of both military missiles and civilian space launch vehicles. As such, the V-2 stands as a significant precursor to the rockets that would eventually carry humans beyond Earth's atmosphere. The Messerschmitt Me-262 marked a turning point in aviation history as the world's first operational jet-powered fighter aircraft. Introduced by Germany during World War II, the Me-262 boasted speeds far surpassing those of Allied piston-engine planes, reaching over 500 miles per hour. Its sleek, swept-wing design reduced drag and improved aerodynamic performance, giving it a distinct advantage in both speed and maneuverability. Allied pilots often found themselves outpaced and outmaneuvered by this revolutionary aircraft. Despite its technological superiority, the Me-262's impact was limited by production delays and fuel shortages. Nonetheless, its innovations paved the way for the jet age, influencing aircraft design for decades to come. The Horten Ho 2E9 was a revolutionary aircraft developed by Germany during World War II. Its unique flying wing design minimized the use of vertical surfaces, which significantly reduced its radar cross-section. This made the Ho 229 one of the earliest examples of stealth technology, decades before the concept became mainstream in aviation. Engineers believed that its shape and construction materials could help it evade Allied radar detection, giving it a potential edge in aerial combat. Although the aircraft never saw mass production or combat, its innovative design influenced the development of modern stealth aircraft. The Ho-Tu-29 remains a testament to the advanced engineering concepts explored during the war. During World War II, German engineers developed advanced submarines known as U-boats, with the Type Y-1 representing a significant leap in technology. This new class featured improved underwater speed, greater operational range, and enhanced stealth capabilities. Had these submarines been deployed earlier in the conflict, they could have posed a serious threat to Allied supply lines across the Atlantic. The Type 81's ability to remain submerged for extended periods made it particularly difficult to detect and counter. Such advancements might have allowed Germany to disrupt the flow of troops, equipment, and resources vital to the Allied war effort. However, delays in production and deployment meant that these formidable vessels arrived too late to alter the course of the war. The Maus was a German super-heavy tank developed during World War II, designed to be the most formidable armored vehicle of its time. Weighing nearly 190 tons, it featured exceptionally thick armor and a powerful 128mm main gun, making it nearly impervious to most contemporary anti-tank weapons. The intended battlefield role of the Maus was to spearhead assaults, break through fortified enemy lines, and withstand intense firepower. However, its immense weight led to significant mobility issues, rendering it incapable of crossing most bridges and limiting its operational range. Production was hampered by resource shortages and Allied bombing rates, resulting in only 2 prototypes being completed. Ultimately, the Maus never saw significant combat, as its impractical design and logistical challenges outweighed its intended advantages. During World War II, the Nazi regime initiated the America Bomber Project, an ambitious plan to develop a long-range bomber capable of striking targets in the United States. The goal was to design an aircraft with enough range and payload to cross the Atlantic Ocean and return safely to Europe. Several German aviation companies, including Messerschmitt and Junkers, submitted proposals featuring advanced engineering concepts. Despite extensive research and prototype development, technical challenges and resource limitations prevented the project from reaching fruition. Ultimately, no operational America bomber was ever produced, but the idea reflected the far-reaching ambitions of the Nazi war machine. During World War II, Nazi Germany pursued the development of an atomic bomb, driven by both scientific curiosity and the desire for military supremacy. The project brought together some of the era's most prominent physicists who faced significant technical and logistical obstacles. Scarcity of resources, Allied bombing campaigns, and internal competition hindered progress. Additionally, the scientific community grappled with profound ethical questions about the destructive potential of nuclear weapons. Ultimately, these challenges, combined with miscalculations and a lack of coordinated effort, meant that the Nazi atomic bomb project never came close to fruition. The legacy of this endeavor highlights the complex interplay between science, ethics, and the realities of war. During World War II, rumors swirled about the existence of Nazi superweapons, with the so-called sun gun capturing imaginations worldwide. This ambitious concept involved a massive space mirror designed to focus sunlight onto targets on Earth, effectively creating a devastating heat ray. While such ideas made for sensational headlines, historical evidence shows that most of these projects remain firmly in the realm of speculation or science fiction. The sun gun, along with other alleged superweapons, was never close to practical realization due to technological and logistical limitations of the era. Many of these myths were fueled by wartime propaganda and post-war fascination with secret Nazi technology. In reality, the most advanced weapons developed by the regime, such as the V-2 rocket, were impressive but far less fantastical than the legends suggest. By examining the facts, we can better understand the line between genuine innovation and exaggerated myth in the history of wartime weaponry. Secret research facilities like Peenemünde played a pivotal role in the advancement of Nazi weapons technology during World War II. Hidden from public view and heavily guarded, these sites became centers for innovation and experimentation. At Peenemünde, scientists and engineers developed groundbreaking weapons, including the V-2 rocket, which was the world's first long-range guided ballistic missile. The work conducted here not only pushed the boundaries of military technology, but also laid the foundation for post-war developments in rocketry and space exploration. The secrecy surrounding these facilities allowed for rapid progress as researchers operated with significant resources and minimal external interference. Ultimately, the efforts at places like Peenemünde significantly influenced the course of the war and the future of technological warfare. Allied intelligence agencies played a crucial role in undermining Nazi weapons development during World War II. Through espionage, they gathered valuable information about secret German projects, such as the V-2 rocket program. This intelligence enabled the Allies to identify and target key research facilities and manufacturing sites. Strategic bombing campaigns were then launched to disrupt production lines and delay the deployment of advanced weaponry. Sabotage operations, often carried out by resistance groups with Allied support, further hampered progress by damaging equipment and infrastructure. These combined efforts significantly slowed the Nazis' ability to field new and potentially game-changing weapons, contributing to the overall Allied victory. Despite ambitious plans and significant investment, the development of these weapons was hampered by persistent resource shortages. Essential materials and skilled labor were often redirected to other priorities, leaving critical projects underfunded and understaffed. Bureaucratic infighting further slowed progress, as competing agencies and military branches struggled to coordinate their efforts. Technical challenges also proved formidable, with many designs encountering unforeseen engineering problems. As a result, these weapons failed to reach mass production or operational readiness in time to influence the outcome of the war. After World War II, both the United States and the Soviet Union raced to acquire captured Nazi technology and expertise. German scientists, engineers, and their inventions, ranging from advanced rockets to jet aircraft, became highly sought-after assets. Programs like Operation Paperclip brought many of these experts to the United States, where their knowledge directly contributed to the development of ballistic missiles and the space program. Similarly, the Soviet Union integrated German innovations into its own military projects. This transfer of technology played a crucial role in shaping the early stages of the Cold War arms race. Many modern military advancements, including guided missiles and stealth technology, trace their origins back to breakthroughs first achieved in wartime Germany. In evaluating these secret weapons, it's clear that while some held remarkable potential, none were decisive enough to single-handedly change the course of World War II. Many of these innovations arrived too late, were plagued by technical issues, or lacked the necessary resources for mass deployment. Their development, however, pushed the boundaries of science and technology, influencing post-war advancements in military and civilian fields alike. The race to create such weapons underscored the importance of innovation, but also highlighted the dangers of over-reliance on unproven technology. Ultimately, the lessons learned remind us that while technological breakthroughs can offer advantages, strategy, logistics, and human resolve remain critical factors in determining the outcome of conflict.